This presentation aims to focus on the relationship between shape and architecture, between shape and structure in contemporary architecture. A big part of the contemporary architectural production shows today a gradual and substantial departure from the themes related to the ethics of construction and structural coherence of the project. The main objective seems to be to pursue figurative intents, highly acclaimed as spectacular. The dimensional prominence and the geometrical complexity of these architectures do not always correspond to actual tectonic coherence of the building, in a sort of contradiction between how architecture looks and how architecture actually is. The attempt to recover a unitary conception of architecture based on a fruitful collaboration between arts and techno invites us to reflect on how the wealth of scientific and technical knowledge has been integrated with the architectural culture over the centuries, and has helped to delineate the awareness that can significantly affect the design process, both in the architecture of the past and in modern and contemporary architecture. Form improving and form finding mean two different operational approaches to the problem of creating new shapes, having the fundamental requirements of consistency, necessity, and expedience of the architectural project. New shapes refers in particular to free shapes and shells, on the whole to non-linear surfaces, which can, for example, the result of a structural optimization problem. Aside to traditional methods of structural analysis like FEM, there are new methods of optimization ranging from structural shape optimization to topology optimization methods, offering nowadays a wide range of design possibilities to the designers. These methods have been extensively explored in various fields of engineering and industrial design, beginning now to be exploited also in architecture as powerful auxiliary instruments to research or invent such new shapes. The intensive employ of software allowing this to control these surfaces by a mechanical numerical analysis put essentially the designer in front of two choices: to highlight the behavior, the conceptual aspect of the formal expression, followed by the fine-tuning of the structural behavior. To pursue then a planning method that preserves the centrality of the architectural vision from its translation in material immanence, and firmly keeps away the creative phase from the stage of verification and implementation. The second option is to start from a more flexible range of shape research, as for example the function or the available design space, never disregarding the overall optimal structural behavior. The software will prompt in every evolutionary stage of the project all the optimal spatial setups to mechanical purposes. Anyhow, it is worth noting that there is no tool that able to completely replace the designer's direct control of every single evolutionary stage. The choice between these two different operative approaches becomes crucial when dealing with shape-resistant structures, where it is not possible to separate the formal characteristic of the structural behavior of the project. It is worth noting in this regard the work made during these very last years by the architect Arati Sozaki in collaboration with the engineer Mutsuro Sasaki. The Kitagata Community Center in Gifu, Japan, is an interesting example of application of the shape sensitivity analysis method, leading to a satisfactory agreement between searching of structural efficiency and formal outcome. The engineer Mutsuro Sasaki, after his researches at Osei University, has developed a methodological approach to the creation of freeform structural shapes based on evolution and self-organization principle. The Kitagata Community Center offered him the opportunity to test it directly on the stage. The initial conditions in terms of height and volume, together with its functional requirements decided by the architect, are established as design parameters. The design variables are altered several times by computer calculation until the actual determination of the best fitting solution. Shape sensitivity analysis has also been fruitfully used for the creation of the structural shape of the island city Central Park Green in Fukuoka, Japan. An undulating helix in which the outer surface and the inner surface are reversed in 2 places. This is an extremely complex structural shape with an overall topological continuity between outside and inside. The green roof enables the building to merge into the surrounding landscape and allows the people to walk on it. With soil, vegetation, and the people. It was calculated on the basis of an exceptionally heavy light load of 1.5 tons of a square meter. A model with initial geometry drawn by the architect Toyo Ito has been taken as the initial shape and subjected to the shape sensitivity analysis workflow. The entire roof was examined by means of shape sensitivity analysis based on a structural optimization method with assumptions coming from constraint condition, material, and dominant load. The structural safety of the final shape has been examined through ordinary FEM analysis by commercially available software such as Nestor. Here we can see some interesting pictures taken during the realization of the reinforced concrete roof. And obviously here, once again, the final result. As you can see, it's a very complex structure, but the result is quite, in harmony with the surrounding. Another example of architectural structural optimization is the project of the Qatar Education City, always by the couple Isazaki and Sasaki. The roof is sustained by a tree-like structural form, which is the result of a topological optimization. Inspired by the shape of the banyan trees in subtropical areas, this kind of structure, defined by Sasaki himself as flux structure, results from a process called extended evolutionary structural optimization, a mechanical theory which uses von Mises yield stress as a reference value, making the shape evolving toward uniform stress. Despite the suggestive final shape, this project reveals a sort of dichotomy between the continuous final form, even called flux structure, and the discrete nature of the actual truss-like structure. Noting that the creative invention is not a matter of geniality, but rather the expression of an articulated system of rules settled by culture and experience, it seems useful to skip into the scenarios delineated by wide possibilities offered by the most advanced software for the research of new rules.